Let's continue on probability distribution, and we're going to concentrate on the binomial probability distribution. Binomial distribution. That's allow us to deal with the circumstances in which the outcomes belong to two relevant categories such as acceptable, defective, and a DVD case, or survive to die, or success or failure. So if you think about this case, when you flip coin 10 times, you want to concentrate on and count number of heads. So basically this is a typical example of binomial probability distribution. Here we have two categories, outcomes in two categories. Either you get a head or tail. If you're betting on heads, then head is what we call a success, and tails are the failure event. Success or failure. Second one, we have 10 trials. We have fixed number of trials here. Third one, trials are independent, meaning every time you flip coin, the outcome is not guaranteed. Outcome is random. Also, the last condition is probability of success, probability of head remain constant throughout all trials. Probability of head remain the same. So basically that's the four basic requirements for the binomial probability distribution. So binomial probability distribution results from the procedure meets all the following requirements. Fixed number of trials, first one. Procedure has fixed number of trials. Flip a coin 10 times. Times the fixed number of trials. So we have 10 trials here. The trials must be independent. So getting the first head does not guarantee you getting the head throughout the whole trials. Each trial must have all outcomes classified into two categories here. Head or tail, commonly referred as success or failure. So getting head is a success, getting a tail is a failure. The probability of success remains the same in all the trials. Okay, so probability of head remains the same. Let's take a look at some notation for binomial probability distribution. Success or failure denote two possible category outcomes, P and Q. P represent probability of success. Q represent probability of failure. They are complement, either have a success event or failure event. So P and Q, if you're adding P and Q, it's equal to 1. They are complement. Success events and failure events are complement. Well, let's take a look at more notations. N's represent fixed number of trials. X represent a number of successes. Let's say flip a coin 10 times, you want to get 5 heads. Getting 5 heads. Here, 5 heads is what we call number of successes in 10 trials. So x could be any whole number between 0 and a sample size n. Okay. P represents probability of success or probability of head in this free pin coin case in one of the n trials. Q represents probability of failure in one of the n trials. P of x represents probability of getting exactly x successes among the n trials. Here we're getting 5 heads out of 10 trials. Okay. And those notation are important. X and P both refer to the same category called success event. And here success and failure are neutral terms. So we do not say success is a good thing or failure is a bad thing. They are neutral events, successes and failure are neutral. So it's neither good or bad. And sampling without replacement consider event to be independent if the sample size, n is the sample size, is less than 5% of population size. Capital letter N will represent population size. Okay. Now let's take a look at this. A random variable, typically represented by x, has a single numerical value occurring by chance for each outcome of procedure. We typically call this discrete random variable. So probability distribution is a graph table formula that gives the probability for each value of the random variable. Let's take a look at this example. Gender of children. So study consists of randomly selecting 14 newborn babies and counting number of girls in a sample. We're assuming that having a boy or a girl is equally likely, and let x represent number of girls among the 14 babies. Here x is a random variable because its value depends on the chance. So you may have 0 girls, 1 girl, 2 girls, all the way to 14 girls. So possible value for x is 0 all the way to 14. As you can see, this is definitely the discrete random variable. It's finite countable numerical number. And the distribution, probability distribution, look like this. We can easily get it from in Excel. I'll show you a little bit later on. Probability of girls, you can have 0 girls all the way to 14 girls, anything in between. And the second column represents probability associated with each discrete random variable. As you can see, getting 0 girl or 14 girl are highly unlikely because the probability is very low. 1 girl, 13 girl, that's still highly unlikely. And then if you look at these numbers, they're symmetrical, right? 1 represents 13, they have the same probability. So let's say getting 1 girl, meaning 13 boys, and getting 13 girls, they are equivalent. 13 girls, 1 boy. As you can see, since the chances are equally likely, so getting a boy or girl is equally likely. So getting 1 girl, 13 boys is similar to getting 13 girls, 1 boy. Okay. Same thing for 2 girls and 12 girls. Same probability. Right, so let's take a look at example. When an adult is randomly selected, that's a 0.85 probability that the person knows what Twitter is. Suppose we want to find the probability that exactly 3 out of 5 randomly selected adults know Twitter. Does this procedure result in binomial distribution? First of all, there are 5 trials, right? So fixed number of trials. Also, they are independent because they are randomly selected adults. So they are independent. So first outcome fixed number of trials. Second one, trials are independent because randomly selected nature. Third one, probability of success remains the same, it's 0.85 because that's percentage probability that adult no Twitter. Probability of success or probability of failure remains as constant. The fourth condition is outcomes in two categories. You either the adult know Twitter or do not know Twitter. Knowing Twitter will be the success event. No Twitter, success event. Not no Twitter, failure event. Okay. So for all four conditions satisfied, and we know that this is binomial probability distribution. So we'll now take a look at different methods for finding the probability corresponding to random variable x, the binomial distribution. First one is using the binomial formula. So P of x equal to n factorial. This is also, as you know, is NCX, right? This is actually combination, picking x successes out of n trials. And then after that, you arrange them with you arrange them in different. So using probability to arrange them, p to the x times q n minus x. So x here could be 0 all the way to n, right? So this is basically the formula. Just keep a note on the formula. N represents number of trials, x number of successes, n trials, p probability of success, n trial, q is probability of failure. So we know all those four, and we can find out probability for any given random variable. Now, you can use any software like Statistics, Minitab, Excel, SPSS, SAS, and TI-83, 85, 84 plus calculator, or TI-80, 91, 92, 93, all good. Could be used to find a binomial probability distribution. This will be what the outcome look like. But let me show you how to get that in Excel really quickly. Okay. Now, given there's a 0.85 probability that any given adult know Twitter, use a binomial probability formulas to find a probability of getting exactly 3 adults who know of Twitter when 5 adults are randomly selected. First of all, you always need to check the requirement. Check those 4 requirements. First one, fixed number of trials. We have 5 trials. That's why n equal to 5. Okay. Second one, we want 3 successes, right? X equal to 3. Second one is the trials are independent because they are randomly selected. Trials are independent. Okay, third one, probability of success remain constant, which is always 0.85. Probability of anyone knowing Twitter is 0.85. Probability of failure remain constant. Probability of failure also remain constant, 0.15. It's a complement of probability of success. Fourth condition is outcomes in two categories, either knowing Twitter no Twitter success event, do not know Twitter failure event, not know Twitter failure event. Well, definitely this is a binomial probability distribution. And once we know that, we can apply the binomial formula. So P of x equal to n factorial over n minus x factorial times x factorial times p to the x q n minus x. And just apply the formula. So here we're looking for p of 3. Okay, so it's n factorial. N here is 5 factorial over 3 factorial over 5 minus 3 factorial times 0.85, that's p raised to third power, 0.15 q, and raised to the second power is 5 minus 3, so second power. If you simplify this, you get 5 factorial is 5 times 4 times 3 times 2 times 1. This is 2 factorial, and 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. Again, we cancel all these numbers after 3. 5 times 4, 20 over 2 is 10. And let's see what is 0.85 to the third power. That's 0.61. 4125. 0.15 to the second power. 0.0225. Okay, so now we proceed. It will be 10 times 0.614125 times 0.0225. And the result should be, let's see. Okay, we can easily do this in Excel. So now it'll be 0.1381 78 125. So typically we run it to 3 decimal places. So this is approximately 0.138. So with 13.8% of chance, we're gonna have 3 out of 5 adults who know Twitter. Now let me show you how to. Now let's take a look at this, another example, gender of children. The study consists of randomly selecting 14 newborn babies, finding probability of having 7 girls out of 14 newborn babies, assuming having a boy or a girl equally likely. Okay. So here n equals 14, x equals 7, we want 7 successes. They are equally likely, meaning probability of success p is 0.5, probability of failure getting a boy is 0.5. Okay, we know all of this. Now we can use the binomial probability formula to find this. So p of x equal to n factorial over n minus x factorial times x factorial times p to the x times q raised to n minus x. And we're assuming they are Now equally likely. Okay, so n is equal to 14, so 14 factorial over 7 factorial times 7 factorial times 0.5 to the 7th and 0.5 to the 7th. 14 minus 7 is also 7. Okay. We plug in all the numbers. And let's get a, here you can use calculator to get 14C7. That will be 32. 0.5 to the 7th power, 0.5 to the 14th power. So that's point. This is 0.00061,035. If you multiply them, you're going to get approximately 0.209, approximately. If you look at this, it should be the same as this, see? Okay, so that's how we find the binomial probability distribution. So basically you can calculate either one of these probability here, just like what we did. X equals 7 meaning getting 7 girls. Okay. Now rationale for binomial probability formula is we're picking X successes out of n trials. Okay. And the probability of X successes among n trials for any of this particular order be P to the X and Q n minus X. So P to the X successes. Many of them will be failures. Okay. Let me show you how to do this in Excel. For example, n equal to 14 newborn babies, X equals 7, and then P equal to 0.5, Q equal to 0.5. So the binomial probability in this case will be equal to, we do BI in OM, DIST. So we put in number of successes is 7. Trials, 14 trials, probability of success 0.5. It's non-cumulative force. In this case, you get this exactly 0.209 if you run it to 3 decimal places. That's how you find the binomial probability distribution in Excel. For the other example, Twitter example, very similar. Here n equal to 5, X equal to 3, and the probability of success P equal to 0.85. Q equal to 0.15. So the binomial probability for 3 adults out of 5 adults who know Twitter will be BIM. The DIST binomial distribution Number of successes goes first, will be 3. Number of trials, 5. Probability of success, 0.85. And false. It's not cumulative frequency. So, okay. And again, if you reduce to 3 decimal places, that should be exactly the one you have in the calculation.